Hi everyone. The problem now that we are going to solve involves the input table as stocks. This table has below columns stock ID, which is the ID of the stock name, which is the name of the stock date, that is the entry of the stock on a particular date, stock price, that is the price of the stock on a particular day. So every entry represents the stock information of a particular day as to what was its price. So this is the input that we have. As part of the output, what we need is for each of the stock, we need to find out when we will purchase and when we will sell it such that we will get the maximum profit. So for example, let's take the example of the first share, that is Vikas Lifecare. So if we purchased it on 7th September at price 5 for a single share and sold it on 8th of September at 5.25, we will get profit of 0.25, that is 5.25 minus 5, so 0.25 profit on a single share. And among all these entries, this is the best possible combination considering the fact that the selling has to be done after the buying and it has to be done from the next day onwards. So this will be the best possible combination. So for every share, we have to find the best possible combination of buy and sell such that we get the maximum profit. So let's work on this problem and try to get this output. So what we will do is, so basically this is the data that we have. Now what we will do is we will create two tables out of it. Okay, so kind of we will create two copies. One we will call as the buy table and one we will call as the sell table. So it's kind of a self join that we are going towards. So we will be understanding how we are going to approach this problem as well as writing the query together. So step by step, let's proceed. So now we will operate on this input table, that is stocks. So what we will do is, first of all, we will call the table as say B. The by table, we will give the alias as B. We will do a inner join and we will take the same table and let's call it as S, meaning that this is the selling table and this is the buy table. So now we have created the two tables. We need to understand what should be the joining condition. So now as we know, whenever we buy a share, for example, if we have purchased this share, we cannot sell it on the same day. We can sell it from the next day onwards as per the criteria of this problem. So given this criteria, what we can do is, so first of all, we have to ensure that in this two table, we are joining on the same stock. So for example, we are joining on the same stock ID. So that will be one criteria. The second criteria will be the stock date in the buy table. It should be less than the stock date in the sell table, as the stock will be sold after it is purchased from next day onwards. So these two criteria we will have. We will first have the criteria on the stock ID, the joining criteria, and second criteria will be on the stock date. So that for each record, for example, this record, the corresponding records from the cell table will be these ones which are highlighted. So we will write the join condition. So how it will be? It will be stock ID of the buy table equal to the stock ID of the sell table. Secondly, we will also add the condition that the stock date of the buy table should be less than the stock date of the sell table. These two will be our criteria. So for now, let's fetch all the columns. Later on, we will look for the particular columns. So we have mentioned all the columns from the buy table. We have mentioned all the columns from the sell table. Let's run this and see the output. So this is the output we have. One more thing we will do is we will sort the data so that it is easier to visualize. So we will sort on the stock ID and B dot stock price. So for the buy stock ID and buy purchase table columns, we will do the ordering. So let's see the data now. So as we can see, for every stock ID, for every, okay, not stock price, sorry, it is date on which we have to do. So just execute it. Yeah. So for every buy date, like buy entry that we have corresponding sell entry, as that is the joining condition that we have specified. And secondly, as we notice, the stock date of purchase is less than the stock date of selling. Okay, so these two criteria we have specified here. So for every buy entry, we have all the corresponding sell entries present. Like for example, this is one set. So with the purchase date as 6th of September for this stock, we have all the corresponding sell entries for the same stock. Okay, so this will help us to check for all the combinations. Similarly, for 7th of September, we will have another set created with the sell dates being after the purchase date. So likewise, we have formed all the combinations. Now, one thing to notice here, these columns, the stock ID and stock name, this will be exactly same. What will differ is the stock date and stock price. These two columns will differ in the buy columns and the purchase columns. So now we will start renaming the columns. So stock ID we will keep as it is a common column in both the buy and sell columns. Then we will have the stock name. So from this output, we have now retrieved these two columns. For this, for the third column that we have, that is coming from the buy table, we will name it as the buy date. Similarly, this column is coming from the buy table itself. We will name it as the buy price. So the stock price, this will be the buy price. And we will not keep these two columns as it is a common column. We already have taken care. It's exactly the same value for each of the rows. So we don't need this. And the remaining these two columns are coming from cell table. So we will use that alias and get these columns, and let's name it to sell date for the stock date, and s dot stock price, let's name it as sell price. So now we have renamed the columns and only kept what is required. We have eliminated these two columns as it is kind of redundant data. So now let's run it and just see the changes that we have just done. So uh, we can now visualize our changes here. We have only kept this column once, whatever was redundant column that we have removed. We have renamed these columns to buy date and buy price, which were coming from the buy table, and these are coming from the sell table, and we have renamed it to sell date and sell price. Okay, so now we have this information. Now for each combination, like for each of the records, what we will do is we will do sell price minus buy price. Okay, so that if we are purchasing it for say 5.10 and we are selling it for 5.25, the profit or loss will be calculated as selling price minus buy price. So that will be our profit. So for every record, let's do that. So for that, we will add additional column, and how it will be? It will be s dot stock price minus b dot stock price. That is stock price coming from the selling table minus stock price coming from the buy table. This will give us the single share profit. Let's run and see the output. So we are at this step. So for each and every combination, we have determined how much profit it will give us. Okay. So for example, if we purchase this share on 6th of September, sell it on 7th, we will get a loss of minus 0.10 for a single share. Similarly, there are other combinations. For the same share which was purchased on 6th September, if it is sold on other dates, we will get this as the profit or loss, whatever it is. Like on 8th September, it will give us a profit of 0.15. On 9th of September, the selling price is exactly same, so there is no profit loss. So similarly, for each and every combination, we have the corresponding profit or loss. Okay, so now what we will do is we will move this as part of a CTE and then we will operate on this data. So let's call it as stock CTE. Okay, and we will just remove this order by from here, as we should not have order by condition inside a inner query or inside a CTE. Okay, so our CTE is ready now. What we will do is we will operate on this data. So we will get the data from this CTE. Now, as a next step, what we will do is we have to find out among all these profits that we are getting for a particular stock, in which record we are getting the maximum profit. That is, which combination will fetch us the maximum profit. So for that, what we will do is, first of all, we will keep all the columns. Here, we will use the dense rank function. We can use rank as well. So we will use dense rank and we will do the partitioning based on the stock ID. As for every stock, we have to do separate ranking. So kind of we are doing the grouping on the stock and then we are ordering by the price, the single share profit that we are getting. Based on that, we will do, and we will do it in descending order so that the maximum profit is at the top. Let's call it as RNK column and let's run and see the output. So now for every stock, we have rank equal to 1 for the entry which will give us the max profit. Like for example, for this share, if it is purchased on 7th September at price 5 and sold at 5.25, it will fetch us 0.25 as the profit. And among all the combinations that are there for this stock, this is the maximum profit that it will give. Okay, so likewise for the other stocks as well, if we see for this stock, the entry where rank equal to 1 will give us the maximum profit of 5.05. So this is the entry, like these are the entries where rank is equal to 1 are the ones that we are interested in. So what we will do is let's add whatever data we have just fetched as part of a CTE. Let's call it as profit CTE. So now we will operate on this profit CTE. Okay. So now what we will do is we will simply filter the records and keep only those where rank is equal to 1. Note one thing, in the output we don't need this rank column, we just need the other column. So we will just specify all the columns. So we have stock ID, we have think stock name is the next column. Stock name has been okay. So okay, it is here. Yeah. So we have stock ID, we have stock name, we have the buy date, we have buy price, we have sell date, we have sell price, and we have single share profit. So we have listed out all the columns and now we will fetch only the records where rank is equal to 1. Let's run and see the output. So we have got the output. Now notice one thing. So for every stock, the entry that we have got tries to give us the maximum profit that we can get. So there are some stocks wherein we are not getting any profit. However, it is trying to tell us the least loss that it will cause. Okay, but we are not interested in the loss entries. So what we will do is we will just eliminate such records, saying that we are interested only in the profit records, so that the single share profit is greater than 0. So let's add this filter and run it. So now we have got the required output. For every share, we have determined what will be the best combination of buy price and sell price on particular date, considering that we can sell the stock one day after or any day after that buy date, and we get the maximum profit. So we have computed it. And let's talk about the query that we have written. So this is the query that we have written to retrieve the data. We will just do a quick summary of what has been done here. So first of all, we have created two copies of this same table. We call this as a self join. Whenever the same table is used on the left and right side, it is called as the self join if it is the same table. We have given the alias as B for the left table, which represents the buy table. On the right, we have given the alias as S, which represents the sell table. The joining condition that we have given is join it for the same stock and ensure that from the buy table side, the date is less than the sell table stock date. So this is the joining condition wherein we have tried to fetch all the possible combinations of buy date and sell date along with their respective prices. Also, we have derived one column by subtracting sell date minus buy date. We have got the profit or loss column. So once we have all the possible combinations, what we are doing is we are simply ranking them per stock, that is grouping based on each of the stocks and finding out the ranking based on the profit in the descending order, so that the entry or the combination that gives us the maximum profit is at the top with rank equal to 1. So lastly, what we have done, we have just operated on whatever data we have retrieved, and we have kept only those where rank is equal to 1, so as to give us the maximum profit. In addition, we have ensured that if there is any stock which will never offer any profit, like any combination does not give any profit to us, so using this, we have filtered such entries. So this is the way we have solved this problem and derived the right results. I will be adding the create table and insert statements in the description. Please go through it. If you have any alternate solution, please provide it in the comments. If you found this video useful, please like the video, please share it with your friends. And if you have not yet subscribed, please subscribe the channel and provide your feedback in the comments. Thank you.